Okay, so we have this question, and 0 to infinity e raised to the power of ax negative e raised to the power of bx divided by 1 positive e raised to the power of x times 1 positive e raised to the power of bx times dx. The choices are given as 0, a0, b1, c is a negative b, d is a negative b log 2, and e is a negative b over ab log 2. So how are we going to handle this question? Now this is what is given, so I'm going to take let I be equal to integral 0 to infinity e raised to the power of ax negative e raised to the power of bx divided by 1 positive e raised to the power of ax times 1 positive e raised to the power of bx times dx. Now can I write this as 1 over 1 positive e raised to the power of bx negative 1 over 1 positive e raised to the power of ax? Can I write it like this? Of course, we have the integral 0 to infinity times the dx. Now let me show you this is what reflects this. If I were to take the LCM as 1 positive e raised to the power of bx multiplied with 1 positive e raised to the power of ax, this is the LCM, right? So in the first term I would get 1 positive e raised to the power of ax negative 1 positive e raised to the power of bx. So it's going to be 1 followed by negative e raised to the power of bx. Now negative 1 positive 1 goes off, giving us e raised to the power of ax negative e raised to the power of bx divided by 1 positive e raised to the power of bx times 1 positive e raised to the power of ax times dx. Okay, so this is exactly what we have. Of course, we need to have that dx, but this is just to show you that this is the reflection of this. Okay, now what I'm going to do is I'm going to split this. I'm going to say consider integral 0 to infinity 1 over 1 positive e raised to the power of bx times dx negative 0 to infinity dx over 1 positive e raised to the power of ax. Now this is the split, right? We have split this. Now let me use consider over here. Consider the first term 0 to infinity dx over 1 positive e raised to the power of bx. Okay, now what I wish to do is I would like to take e raised to the power of bx out. If I were to take e raised to the power of bx out, this is going to be 1 over e raised to the power of bx positive 1. Of course there is a dx there. Now in the numerator we do not have any bx, so what I'm going to do is I'm going to rewrite this as bx negative bx times the dx divided by e raised to the power of bx times. Now this can be pushed to the numerator, so it's going to be e raised to the power of negative bx positive 1. Now bx negative bx is 0, so e raised to the power of 0 is going to be 1, so there's no harm done there. Also a raised to the power of m negative n can be rewritten as a raised to the power of m times a raised to the power of negative n. So having got that, let me go and rewrite it in the next page. This is equal to integral 0 to infinity. I am rewriting it as e raised to the power of bx negative bx times dx divided by e raised to the power of bx times e raised to the power of negative bx positive 1. This is what we have. As I mentioned to you, I'm going to rewrite this as e raised to the power of bx multiplied with e raised to the power of negative bx times dx divided by 1 positive e raised to the power of negative bx times e raised to the power of bx. Now e raised to the power of bx, e raised to the power of bx gets cancelled. Of course you have limits as 0 to infinity. So 0 to infinity e raised to the power of negative bx times dx divided by 1 positive e raised to the power of negative bx. Now let me take 1 positive e raised to the power of negative bx to be as sum t. I differentiate, I get e raised to the power of negative bx. Differentiation of negative bx is going to be giving me negative b times the dx is equal to dt. I don't have a negative b, so I just have e raised to the power of negative bx dx. So I'm going to push this as dt over b with the negative sign. So this is going to be, I'm not going to do anything with the limits. I'll come back to the limits within a minute. So e in place of e raised to the power of negative bx e raised to the power of negative bx times dx, you have negative dt over b, okay, divided by 1 positive e raised to the power of negative bx, that's going to be t. So this is equal to negative 1 over b integral dt over t. Now if you want, you can apply the limits. I substitute 0 here. If I substitute x is equal to 0, this is going to produce me e raised to the power of negative 0, that's going to be 1. So 1 positive 1 is going to be 2, okay. So if I substitute infinity, this is going to be e raised to the power of negative infinity, that's going to be 0, okay. So what we can do is we can actually restrain from having the limits and just apply ln t here or log t. So this is going to be negative 1 over b ln, since log is given, I just retain it as log. Log of t is 1 positive e raised to the power of negative bx. So the limits are going to be 0 to infinity. So this is what we got. We got negative 1 over b log of 1 positive e raised to the power of negative bx. The limits are 0 to infinity. So I get negative 1 over b log of 1 positive e raised to the power of negative infinity times b. Okay, so negative of log of 1 positive e raised to the power of 0. Okay, so this is what we are getting. Now this is going to give me 0. E raised to the power of negative infinity is going to be 0. This is going to be log 1. Log 1 is 0. So you have negative 1 over b negative. This is going to give me 1. So 1 positive 1 is log 2. So this is going to be positive 1 over b times log 2. So this is for the first part. Now we have to go to the second part. So consider integral. So what is the second part? The second part is integral dx over 1 positive e raised to the power of x. I can rewrite this as e raised to the power of ax negative ax times the dx divided by e raised to the power of ax times 1 positive e raised to the power of negative ax. Now these two can be cancelled, giving me e raised to the power of negative ax times the dx divided by 1 positive e raised to the power of negative ax. So let 1 positive e raised to the power of negative x be equal to sum u. This is going to give me negative a times e raised to the power of negative ax times dx is equal to du. I got only e raised to the power of negative ax times dx, so it's going to be du over a with a negative sign. I don't want to handle the limits as of now, so it's going to be integral negative 1 over a. In place of this is going to be du, in place of this is going to be u. So this is going to be negative 1 over a log of u, which is nothing but negative 1 over a log of 1 positive e raised to the power of negative ax, 0 to infinity. So I substitute the upper limit. So it's going to be 1 positive e raised to the power of negative infinity, right? And then negative log of 1 positive e raised to the power of 0. So this is going to be 0, so this goes off. This is going to give me 2. So positive 1 over a log 2. But you have this integral 0 to infinity dx over 1 positive e raised to the power of bx negative 0 to infinity dx over 1 positive e raised to the power of ax. Now the first term has given you 1 over b log 2. Second term has given you positive, but there is a negative there, so it's going to be 1 over a log 2. Now actually I have 1 over b negative 1 over a, and that's going to be log 2. I take the LCM as ab, so this is going to give me a negative b times log 2. So the right choice is E. Okay, so this is the only choice where the answer is found, a negative b divided by ab times log 2. Okay, so you can go through this beautiful question. Please like, share and subscribe. Thank you.